starting with our new chapter. Hi guys, hi. Hello, good afternoon, guys. So hope everyone are taking this. Yes. Okay. Now am I audible, guys? Please check if I'm audible. Yes, check if I'm audible or not. If I'm not audible, let me know, guys. Hello, good afternoon, guys. So how's everything going on? So hope everyone is doing good. Yes. Yes. Yes, guys. Hi. So there is a lag, is it? So let me check that. So yeah, yep. Come on, guys. So just a moment, guys. I'll come back to you. Yes. Come on, guys. Hope yeah. Everyone is able to hear me. So let me get S if you are able to hear me. Let me get an S if you are able to hear me. Yes. Come on, guys. Yep. Okay, guys. I see most of you are here, and hope you have started studying. I mean, you have come prepared to the class with whatever I have asked you to study. Say, we are starting with electrostatics today, so we'll be starting with electrostatics now. So yeah, what do you see? What do you know about electrostatics, guys? So yes, quickly take the oath, guys. There are 42 students now. I hope if there are any other students, let me know. So please inform me in your WhatsApp groups, in your school WhatsApp groups, if students are not knowing that there is class now, let them know so that more students could come now and participate in the class. So yes, hi guys. So I'm Pradeep Kumar S, your teacher for physics. Currently in Jain Hassan, and yes, guys. So how are y'all? So let me know. Yep. So let me get yes if you are able to hear me, and yes if you are able to see the screen. Everyone. Hope today we will just resolve what the problems we had in the earlier classes. Like most of you were commenting, or yeah, most of you thought there is no like there was an error right yesterday. So the error was we were not able to schedule, or we were not able to check what's going on, like the non-verbal chats like yes, no, go slower, faster. Is it visible today, guys? Someone please reply if you are able to see today. So is it available today? Yes. Yeah, Kavana, hi. Kavana from Genmich came. Yep. Please let us check that once. Yes. So everyone please click on yes. Click on yes. Everyone. Yeah. This is a quick checkup of how. Yep. Yeah. Yes. I see. Yes. Come on. So click on no, guys. Click on no. Now click on no. Okay. Go slower. Click on go slow. Go slow. Yeah. Again, click on go fast. Yeah, cool. So I'm clearing all responses. So everyone is able to see. Hope everyone is able to see me and hear the board clearly. I mean, sorry, everybody is able to hear me and see the board properly. Yes. So I see out of 61 students, only 54 students have voted for this. So let me know. Yep. Yeah. So there might be a lag in my voice, or there might be some delay in visuals if there is no proper network at your end or at my end. So there is some problem. Okay. And there would be. Okay. Chill. Never mind that. So I'm going to end your poll now. Let's start with our first class of electrostatics. Now, guys, how many of you know what is electrostatics? Electrostatics. What is it? What is electrostatics? Guys, hope all of you have, at least once have completed this chapter. Completed studying this chapter by now. Yes? No? Okay, click on yes if you have at least studied once. Or okay, if you have at least know if you have any basic idea what is electrostatics by now. Okay, so if you don't know, click on no. So anyway, we'll be going from basics. First, we'll be starting with basics. Then we'll be starting with yeah, problem solving. So today, guys, we'll be starting with the most basics of electrostatics. What? And yeah, we'll start with charge, properties of charge, and we'll be learning about Coulomb's law. Yeah, yeah, cool. Then we'll be solving few problems and we'll wind up class. Okay, so anyway, cool guys. So yes, I have received your responses, thank you. So most of you have learned, but some of you might have missed the classes, so don't worry. So guys, quickly, uh-oh, what's happening here? Can you see this? What's happening here? So you see four different gifs, four drawings, four pictures. All are motion pictures. So what do you see in these pictures, guys? Hope everyone can see this. So what do you see in these pictures, guys? What do you see here? What do you see here? This guy. What do you see here first? We'll call this as first picture. This is my second picture. This would be the third picture. And this is my fourth picture. Okay, what do you see here, guys? Okay, see. Oh, hair attracts to the balloon, right? First picture shows air is attracting to the balloon, right? And then second picture, okay, there is a comb. When we rub comb on a paper, when we rub the comb on a cloth and we held the comb near paper, what's happening? The paper is getting stuck to the comb. Did we put any Fevicol there? Did someone put Fevicol there? No, right? Okay, no. Yeah. So why is that happening? Why is it sticking? Oh, okay. So everyone, yeah. So everyone might have seen this lightning, right? What is lightning? How does this happen? Think. How does lightning happen? Yes. And oh my God, we have a balloon here. And if we rub the balloon, we can change the direction of flow of water. Awesome, right? So we see hair, hairs attracted to the balloon, paper attracted to comb, lightning, and bending of water. Now, what is happening? Let us take time and think. Okay, you guys should answer me in the chat. Why is this happening? Okay, hairs are being attracted. Okay, now answer for this. Why is our hairs being attracted? Yes, I'm waiting for the answer. So why is our hairs being attracted? Hairs are attracted, right? Hairs are attracted to the balloon. Why is that happening? Okay. Apurva Samar say charges. Okay, which charges? Okay, electrostatic attraction. Muhammad Sahin Kavya. Yeah, come on. Yes. So most of you are saying, okay, they are unlike charges. Okay. Then, why do you think paper attracted to comb? Why do you think paper is attracted to comb? Okay, electrostatic force of attraction between charges. Fine. Okay. Any other things? Okay, what is lightning doing here? How do we get lightning? So if you know these two, then why do we get lightning? How does lightning happen? Anyone know? Yeah. Okay, guys. Then, yeah, if lightning is happening in that way, okay, developing charges within, cool. Then, so last one, why does water bend? Did someone put any pipe there? No, right? Why did water bend? Is water having any charge, guys? Okay, I know in all other three cases we got charges, yes, but is water having any charge? Is our water having any charge? Okay, you getting my question? Okay, water has charge. Is it? Does water have any charge? Oh, okay. Okay, let's see what I got. So, oh, H2 atoms has cool. So, what did you learn after testing? What did you learn from these? Okay, cool, guys, awesome. So, what did you learn from this? See, when you rub, okay, in this first example, when you rub your balloon on your hair, what happens? So, when we rub our balloon on the hair, what happens? Hair loses some electrons. So our hair, which was neutral, when we rub the balloon, what happens? It lost the negative charges. I mean, hair loses some electrons, whatever the electrons. So we know we have positive set of charges and negative set of charges, and these two charges are always held together, and these two form a what pair? Neutral pair, right? So when we rub the balloon, what happens? When we rub the balloon, we are doing some we are doing some work. We are doing some work such that the hair, whatever the hair we have, it loses electrons. To where? Where does it lose the electron? Yes, it loses the electrons to the balloon. Okay. So when it loses the electrons, the hair gets positive charge, and the balloon which receives the electrons will gain a negative charge. Yes. Bam. So both are attracted. Okay, first case I do. Second case. What happens to the comb? Okay, when we rub, okay, balloon I understood. What happens to the comb? It's the same phenomenon, is it? Yes. So on rubbing the comb with cloth, so instead of hair, we have the cloth here. Yes, Shashwita. Shashwita, right? Please ask your doubts. You have raised your hand. Okay. Negative charge, correct. Okay. So on rubbing the comb with the cloth, what charge does the cloth get? Guys, answer in the polls. So what charge do you get in the? Yes. Okay, cool. Chill. Okay. Yeah, guys, come on. On rubbing the comb with the cloth, what charge does the cloth get? Okay, some people are replying positive. Some people are replying negative. What's the correct one? I need more answers. Okay, come on. Out of 107, only received 7. Oh, shame. Okay, chill, guys. Yeah. Okay, some say positive and some say negative, and depends on the material. Now I have given the material, guys. So I'm rubbing my comb on a cloth. So I'm rubbing the comb with the cloth. So here, what charge does the cloth get? What charge does the comb get? Yes. Okay. So the comb gains electrons from cloth. So the comb, what happens? The comb gets electron from the cloth, and yeah, it becomes negatively charged. The comb becomes negatively charged. All the electrons which are from in the cloth will be gained from the comb. Okay. The comb gains the negative charge, and all the papers here, the bits of papers here which we had, these papers will get positively charged. Henge. How? So the cloth gets positively charged and the comb gets negatively charged. Now the paper attracts to comb. The charged comb induces an opposite charge on the paper and it attracts. Okay, Nandan Hegde. Hi. Nandan Hegde, please ask your doubt. You have raised your hand. Please ask your doubt in chat box. So how to determine which gets positive and which gets negative? So it depends. It depends on the properties of the material. Okay. So yeah, there are certain things which you have to know. Okay, it depends on the properties. Yeah. So here the comb gets the negatively charged and the cloth gets positively charged, and the paper which was neutral, when we held the comb near the paper, what happened? The paper got attracted. What happened there? So the comb which was charged, the charged comb here induced a opposite charge on paper. So induced an opposite charge on paper. We'll study today what is induction. What is induction? Okay, guys. Last one. Okay, now last second one. What happened when lightning happens? What happens? So I need a clear-cut answer for this. Can you guys explain? So how do we get lightning? Do we have someone holding the charge? guys? Think on that. Okay, it's an electric discharge. Yes, yes, correct, Aditya. So it's an electric discharge, right? But what? Who gives the charge? From where do we get the charge? Okay, atmospheric charges. Okay, then ions in the sky. Earth is full of negative. Oh no. Okay. Ions in sky at clouds. Okay, cool guys. So what happens is, okay, when lightning occurs, what happens is the charge is formed on the clouds due to rubbing of clouds. So you know, right? The clouds are continuously moving. The clouds are continuously moving. Now these two clouds initially maybe they are neutral. Now what happens? After some time they start to collide with each other. You know, so what happens? It collides with each other, then it rubs. So when it rubs, what happens then? The clouds which are having charges, so one cloud in the inner cloud, so charges from one cloud move to another cloud, creating a net positive and negative charges. Now when these clouds accumulate charges, so after rubbing, continuous rubbing, what happens? The clouds give out, yeah, the clouds explode, or sometimes, yeah, it gives out a jolt of electric shock, right? Sudden shock. So these negative charges which are present in the cloud are stored, and they at the moment, like an impulse, it shoots out, or it discharges all the charges which are present in it to the ground. So that is how the negative charges, after accumulating in large numbers, they hit the ground. That's how we get the lightning. Okay. So last one. So when a charged balloon is brought near a faucet, so we have a faucet, and so it's just a tap with water, running water. Yes, yes, Prajwal. Yeah, you raise the hand. Please ask it out. Correct. When cloud strikes each other, correct. So when a charged balloon is brought near a faucet, what happens? What happens is, so there is water always running out, right? So this water, which was again neutral, water is basically neutral. It is chargeless, okay? Unless we do some work. So unless we supply, say like in your chemistry, you might have studied, right? Water is consisting of H2O. So maybe you might be confused with this, like H plus and OH minus ions. Yes, this is possible, but for this to occur, we have to supply some DC electric current. We have to supply some DC electric current, okay? Unless we supply DC electric current, this won't split. So by nature, water is neutral, okay? By nature, water is neutral. So what happens when we bring a charged balloon? So we have a charged balloon here. So the charged balloon. So when we bring the charged balloon near this, what happens? What happens is, so, oh my God. So when we bring a charged balloon near the faucet, what happens is, okay, the negatively charged balloon attracts the water towards itself. So the balloon which was charged negative, okay, oh shit. Okay, guys. So the negatively charged balloon, which was there, the negatively charged balloon attracts the water towards itself. Then what happens? Yeah, it bends. The water bends. Okay. Now, what is common in all these, guys? So if you see the hair attracting to the balloon, the comb attracting to the paper, the lightning, and the charges, I mean, bending of water. What's common in all these? What's common in all these? So it's either attraction or it's discharge. Okay, that's what one of your students says. Others, please answer. What is common in all this? If you see all four examples, what is common? Okay, okay, rubbing is common. Cool. So charges. So one of your students says charges. So what type of charges? Yes, charges are acting. Okay. What type of charges? So something which is common is, guys, what is common? Okay. Okay, I need more answers. Come on. Okay. Okay. Okay, I see attraction of unlike charges. Okay, so what are these? Yes, correct, correct. Only one answer I got and accurately. All others are also correct. So, yes. Do you think? Did you think? Okay, okay. So someone answered this. In all cases, we would see the charges are stationary, right? If you see in all these cases, all four cases, the charges were stationary at some point. At one or the other point, the charges were stationary. For example, here in this case, okay, here in this case, when we had the balloon, okay, when we had the balloon here was having some negative